Job is to make sure the engineers and the technicians all physically put all these boxes that you've been hearing, bolts and all onto a spacecraft altogether.
I gotta ask, with a mission so ambitious, how many hours, how many years, how many people? Do you have any idea at this point?
Oh man, so I mean, DART has been thought about for a long time, but really started in earnest about 5 years ago. We started building up the spacecraft, and in that assembly that I was talking about 2.5 years ago. And so it's been hundreds of hours, to make something like this possible. People with all sorts of talents. You've seen a lot of them today.
That's incredible. And so we're heading up toward another SAS update, as I said earlier. And as we all know, space is a unique and challenging environment. When you're assembling DART, what were the key boxes you were checking off of that very long quality assurance list to get the spacecraft to where it is right now and hopefully till impact?
So space is very hard, and so what we do is each individual component, Lisa was talking about this earlier, goes through its own individual testing, and then we put the whole spacecraft together, and we will check out the electrical systems, making sure all the boxes are working and talking to each other. We put it into a vacuum chamber, make sure it's going to work in space, put it through all the different temperatures it's going to see, and then put it on a shaker table and actually mimic launch, so it actually goes through all of that as a full spacecraft as well.
السلام عليكم. بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله. Soyez le bienvenu. Hi everybody. إذن بثنا الليلة مباشر مع وكالة ناسا لمعايشة الحدث الفلكي الكبير، وهو محاولة تغيير وجهة كويكب. نعرف أن الكويكبات هي كواكب صغيرة الحجم، معناتها عبارة على كوكب ولكن هو صغير برشا مقارنة بالكواكب الأخرى. إذن الكويكبات هذه متواجدة في الفضاء كأنها غبار فضائي أو مخلفات كواكب أخرى. ولوحظ أن الكويكبات هذه عندها مسارات متعددة. يخافوا أن تقع مرة من المرات أن كويكب في المسار متاعها يصطدم بالأرض، وخاصة وأن الأبحاث بيّنت أن تاريخ الأرض تغيرت الحياة على الأرض باصطدام كويكب بالكرة الأرضية، اللي هو غير المناخ من الحقبة الجليدية إلى ما بعده، وانقراض الديناصورات إلى آخره. حسب الأبحاث تقريبا هو كويكب اصطدم بالكرة الأرضية. كذلك القمر، يقال آخر الدراسات أن القمر هو جزء من الأرض. كويكب اصطدم بالأرض واقتطع منها قطعة وابتعدت عن الأرض شيئا فشيئا، وبدأت تدور حول الأرض بحكم الجاذبية إلى آخره، لأن تطورت وأصبحت القمر لما هو عليه الآن، الشكل اللي نعرفه للقمر. إذن يخافوا من اصطدام كويكب بالكرة الأرضية، ينجم يدمر الحياة على الأرض. إذن فكروا العلماء في أن كويكب إذا شافوا أن باش يصطدم بالأرض ينجموا يدافعوا على الأرض ويضربوا الكويكب هذا بشيء ما باش يا إما ينكسر يتكسر يمشي قطع صغيرة ما عادش يضر الأرض، معناه يحترق في الغلاف الجوي، أو أن يغيروا له الوجهة متاعه. وهو تجربة الحال الليلة هي تجربة الحال الليلة هي لسوند دارت، هي مسبار أو مركبة صنعت خصيصا للشيء هذا، وأرسلت في نوفمبر 2021 للغرض هذا بالذات. السوند دارت هذه إذن باش تصطدم بالكويكب بعد أقل من شوفوا الوقت الكونت أربور 28 دقيقة من الآن. طبعا حسب التقديرات أقل أكثر ديما ثم نسبة متاع خطأ أو هامش متاع خطأ. إذن قلت المركبة أو السلاح هذايا سوند دارت فيها كاميرا بطبيعة الحال قاعدة تصور، اللي هي تشوفوا فيها توا على الصورة هذاك الكويكب اللي هي مشيت له. هي في الحقيقة ما هيش باش تضرب الكويكب، باش تضرب قمر من أقمار الكويكب، عندها قمر يدور حوله. إذن هي باش تضرب القمر هذايا. نعطيكم بكل دقة التسمية. القمر هذايا ديمورفوس. ديمورفوس هذايا القمر قطره 163 متر، يدور حول الكويكب ديدايموس. ديدايموس هذايا أكبر بطبيعة الحال اللي هو قطره 780 متر. سرعة الاصطدام باش تكون في حوالي 23,000 كيلومتر في الساعة، اللي هي سرعة المركبة دارت حاليا. نشوفوا على الصورة أمامنا لايف دارت كام، هذيك الكاميرا متاع دارت حاليا قاعدة تصور في الكويكب أمامها والقمر الكويكب هذايا. عملية الاصطدام ما يعرفوا عليها حتى شيء، معناتها هي تجربة أولى باش يحاولوا يشوفوا نتائجها، باش يشوفوا نجم نغير المسار متاعها ولا لا، باش يتحطم ولا لا إلى آخره. ثم أمتي ساتيليت إيطاليا هو على متن المركبة دارت. الساتيليت هذا باش يبعد، باش يخرج على دارت طبعا، وباش يصور الحدث، ينقل لنا صور ويمشي للبلاصة هذيك بعد 3 دقائق من الاصطدام باش يعطينا، يحاول يصور شنو هو النتائج إلى آخره. القمر الصناعي هذا صغير جدا، صغير الحجم، قلت باش يبعد على المركبة باش ما يتأثرش بالاصطدام، وهو اللي باش يصور لنا الصور اللي باش نلتقطها. إذا نحن مع بعضنا في مواكبة مباشرة مع وكالة ناسا. الاصطدام باش يكون بعد تقريبا 26 دقيقة من الآن.
What an exciting update, Samson. You just heard it. All systems are go. Mission operations confirm the spacecraft is on track for impact. But in order to hit the mark, the test must first locate its target. That's why Johns Hopkins APL engineer Michelle Chen helped develop new autonomous navigation techniques that will ensure a bullseye. Let's take a look.
Never in my life would I have thought I would take a couple $100 million spacecraft and crash it into an asteroid. My name is Michelle Chen, and I lead the team that is responsible for the autonomous navigation of DART spacecraft to hit an asteroid. The DART mission is the first planetary defense test mission. Our goal is to hit and impact an asteroid to understand and study the momentum transfer so that we could potentially later down the road, if we need to, deflect an asteroid on its way to Earth. I am the SmartNav lead. SmartNav stands for Small Body Maneuvering, Autonomous Real-Time Navigation. SmartNav, I always consider it sort of like the brains. And so the camera, Draco, is essentially the eyes. The algorithm has to identify and hit the target in the field of view of the camera. We're flying at over 6 kilometers a second. It essentially occupies a pixel up until possibly 30 minutes prior to impact. And then that's where everything gets really exciting. And so you could just imagine if it was a human being joysticking this. Because we don't know for sure what the asteroids look like, our simulation gives us the capability to use different asteroid shapes and asteroid objects to see that our SmartNav algorithm performs against all these unknowns. We're super excited and nervous as well. I love pushing the boundaries, and I love the application of math into real-world problems, and then seeing it actually doing its thing. To me, there's nothing cooler than that.
If you're just joining us, we're about 24 minutes away from DART's impact with asteroid Didymorfos. The spacecraft is flying at 4 miles per second, guided only by its autonomous navigation system. I'm here now with Tom Statler, DART program scientist, and Don Graninger, DART impact modeler. Tom, Don, thank you for being here with us tonight. We have some good news happening, but we did just hear about the challenges that DART is facing tonight. So, Don, could you tell us a little bit about what kind of uncertainty exists with a mission like this?
Yeah, sure. So what's really interesting is that until just, even a few minutes ago, I feel like we're just getting our first looks at Didymorfos. And so we have absolutely no idea what we're going to be impacting into. It could be covered in rubble pile. It could be just a completely different shape. We don't know until we really write up on that impact. And that's probably one of our biggest uncertainties on this.
I mean, but that's what really makes tonight so exciting. And so, Tom, could you expand a little bit more on how we will use this information in the future if all goes successfully?
Well, this test is really important to understand how we might be able to deflect asteroids in the future. And when we measure the change in the binary period of Didymorfos, and we will understand how the asteroid reacted to our kinetic impact. And then as we get deeper understanding into exactly what the geology was of that asteroid, that's the basic information that's going to help us refine our physics understanding of asteroids and our ability to compute and predict, like Don does, run these fantastic codes and extend this knowledge to really have a good plan for how we might react if we ever do discover a dangerous asteroid that is different from Didymorfos.
Well, hey, I mean, it's better to be safe than sorry. So it sounds like y'all's party is really just getting started after impact. So congratulations on your success so far. It has been a pleasure. Thank you so much. Now, any second, we should be learning if DART has a precision lock on its target Didymorfos. This is a key milestone critical to tonight's success. Samson, mission operations must be buzzing. How are things going?
Hey, Tahira. The energy is indeed electric, and the team is hyper-focused. You could hear a pin drop right now as we're coming up on the critical 20-minute mark from impact and expecting to hear from the team that SmartNav is now precision-locked onto Didymorfos, which means that SmartNav will be tracking only Didymorfos from here on out. Why? SmartNav has full confidence that we are in fact tracking Didymorfos, and so we want to remove any confusion by continuing to track Didymos. Because what could happen with Didymos is that its shape could be such that there's a lot of shadowing, which could make it seem in the Draco imagery like multiple blobs, as the team likes to call them. And we don't want SmartNav to mistake any of those blobs for Didymorfos, so we're doing away with tracking Didymos altogether. We are waiting for that announcement of precision lock. All right, we're about to hear from the team. Actually, we have some time until we hear that. And now let's listen in for that confirmation of precision lock.
All right, we expect to be in precision lock soon.
are waiting for confirmation of precision lock.
MSC, this is SN5.
Go ahead, SN5.
We are precision locked and still tracking Dimorphos.
Yes.
We are soon going to hear again from Elena
right.
Adams.
This is great. This is Dart MSC on DT Mach. So this was our last milestone. At this point, we're going to be working towards Dimorphos. I expect we're going to do some burns. We're about 4,500 miles away from Didymos and Dimorphos. So let's see what happens.
Ground staff 41, C2.
Right, joining me now to react to that bit of good news is Lindley Johnson, NASA's Planetary Defense Officer. Lindley, you heard Lena, we are now precision locked, a lot of applause, things are looking good. And we are now headed for the moment of truth. How are you holding up?
Oh, I'm doing great. The team's been doing great. The spacecraft's doing great. It's this precision lock, is absolute milestone for the terminal phase here. We've got a good signature on Dimorphos, so the spacecraft has what it needs to guide itself in for the impact here in 17, almost 18 minutes. So we're doing great.
Yep, so close. Very exciting moments ahead. Now, we can't say this enough, and I know you've said it so many times, but it's worth repeating for viewers that Dimorphos is not a threat to Earth, nor will it be after impact, right?
No, that's right. This asteroid system is still almost 7 million miles away from the Earth. It's at its closest point in the orbit right now to Earth. So from this point forward, it's going to be moving away from Earth. So there's no chance of anything here. We've got to look for all the other unknown asteroids out there still.
Awesome.
To find what the hazard really is.
Thanks so much, Lindley. I'll catch you on the other side of impact.
Oh, okay, if you can.
Back to you, Tahira.
All right, thanks, Samson. It is amazing to know that we have a precision lock on target Dimorphos. Now, we have a fun way for you to join our mission, and it is by signing up to be a planetary defender. Visit bity.com/planetary defender. Take the quiz and receive a certificate like this one. Now, once it's official, show us on social media using the hashtag Planetary Defender. Now, telescopes from around the world are observing tonight's impact to ensure that how successful we are at changing the asteroid's orbit. They'll be measuring this success. And you may be wondering, how does that happen? Let's go behind the scenes with astronomer Nick Moskovitz at Lowell Observatory, home to the telescope that discovered Pluto, to see what's in store for DART.
This is Lowell Observatory. Lowell is one of many observatories around the world that will be observing the DART impact, NASA's first ever planetary defense test mission, to see how much a spacecraft impact can deflect an asteroid in its orbit. This is where Pluto was discovered, and we are still doing research in all areas of astronomy today. So let's go check it out. This is the Pluto telescope, the telescope that was used to discover Pluto almost 100 years ago. So here we are at the Clark telescope. This is where Percival Lowell sat to observe Mars. Let's head on over to the Lowell Discovery Telescope, about an hour south of Flagstaff, which is where we are going to be collecting data for the DART mission. The reason we're all the way out here in the middle of this forest is that we have really dark skies here. And this is the Lowell Discovery Telescope. This is what a 4.3 meter telescope looks like. This is what we will be using to study Didymos and Dimorphos in the days and weeks after DART impact. The DART spacecraft will be hitting an asteroid called Dimorphos. So special because it's a binary asteroid, which means a satellite around a larger asteroid called Didymos. And DART will actually be hitting Dimorphos. And what we will be measuring is how much DART changes the orbit of Dimorphos around Didymos. So this is an important test for planetary defense mitigation strategies in case we ever have to do this for real. The Lowell Discovery Telescope is one of many telescopes around the world which will be used to study Didymos and Dimorphos. It's really a global coordinated effort. And what we're looking at here is a large 4.3 meter primary mirror that's in the middle of the telescope tube here. Up at the top is a secondary mirror. The secondary mirror up top there is what is focusing the light down onto the instruments and allows us to take images with the camera that's located down at the bottom. This is maybe one of my favorite hidden rooms at the telescope. We're like standing inside the telescope, underneath the telescope, 100 tons above your head, held up by this and this, which is cool. It's sort of, as you can see, the highest peak around here, just over 8,000 feet. Come up here for sunset. You know, sun setting right there. It's perfect. For DART, we're going to be collecting images of the night sky. And typically an observer would be here in front of one of these consoles controlling the instrument and taking images like these as they're coming in off the telescope. DART is really a sort of before and after experiment. We need to understand the system before the spacecraft intentionally impacts, and then we have to understand what the outcome of that impact event is. As we watch from the Earth, Dimorphos will pass in front of Didymos and behind Didymos. What we will be doing with those images is measuring the brightness of Didymos in those images and looking at how that brightness changes. And those dips in brightness allow us to measure when these eclipses happen and measure the orbit period of Dimorphos. And so you have essentially a fixed star field here. All the white dots are stars of different brightness, and moving through this field is Didymos and Dimorphos, which again, we can't distinguish them as discrete points of light, but we have that small object moving through the field of view. So after impact, we will then be able to go back and start observing intensely, looking for those mutual events, those eclipse events of Dimorphos passing in front of and behind Didymos. And on each one of these frames, we're measuring the brightness to assess whether or not it's undergoing one of these events where Dimorphos is passing in front of or behind, and using those to determine the orbit period of Dimorphos.
إذا مرحبا بكم أصدقائي من جديد. كما قلنا نحن في متابعة مباشرة لهذا الحدث اللي هو الدفاع عن الأرض من خطر داهم من أحد الكويكبات. سيقع محاولة تغيير وجهة هذا الكويكب ديمورفوس اللي هو قمر لكويكب ديدايموس. بعض المعطيات التقنية ديمورفوس هذا 160 متر 163 متر القطر متاعه اللي نشوف فيه أمامنا على الشاشة. هذا هو الكويكب الحجم الكبير 780 متر، والصغير هو القمر اللي يدور حوله، اللي باش تحاول الصوند أو المسبار هذايا أو السلاح دارت باش يحاول يصطدم به لمحاولة تغيير الوجهة متاعه أو تهشيمه تكسيره. طبعا هي تجربة أولى فريدة من نوعها، ما نعرفوش على شنو ممكن يصير. المهم أن تقديرات كلها بالنسبة للخطر على الأرض نطمئن، ما فماش حتى خطر، حتى ولو تغير المسار متاعه هو بعيد نوعا ما على الأرض فماش حتى خطورة. طريقة التصوير، إذا هذه الكاميرا لايف اللي نشوفوا بها هي كاميرا موجودة على متن الكبسولة هذه أو المركبة هذه دارت، قاعدة تصور توا مباشر. وتصوير الاصطدام ثم ساتيليت آخر صغير الحجم باش يبعد عليها، مش باش يقع الاصطدام متاعه، هو باش يبعد ويبقى يصور في الاصطدام دقائق بعد الاصطدام باش نشوفوا شنية النتيجة. مازال 10 دقائق، أقل من 10 دقائق حسب التقديرات طبعا. سرعة هائلة، سرعة في حدود 23,000 كيلومتر في الساعة. في الحقيقة الصوند هذه ما هيش كبيرة الحجم، هي تعمل متر وشوية على متر وشوية على متر وشوية، ما هيش كبيرة الحجم متاعها، في حدود 570 كيلوغرام. وباش نكتشفوا التقنية هذه، أو إذا نجمنا نسموه سلاح. السلاح هذا هو سلاح في السنس الباهي للكلمة، طبعا سلاح دفاعي على الأرض. طبعا هذا تحضير لما يمكن أن يكون يوما ما أسترويد كويكب في اتجاه الأرض ويسبب إشكال على الأرض، إذن يسبب خطر. نحضر رواحنا، البشرية تحضر روحها باش نجم تدافع على الأرض بالطريقة هذه. إن شاء الله الأمور تتعدى كما ينتظروا. هم في الواقع ما ينتظروش في حاجة كبيرة، ما عندهمش معطيات كبيرة اللي يتوقعوا شنو باش يصير. هي مفاجأة، أصور شنو يقع، ما نعرفوش شنو اللي يقع. على كل نحن في متابعة مباشرة. نخلي لكم صوت وكالة ناسا، وربما تعطينا بعض المعطيات.
Really doesn't end until that last second comes to pass. So they can do a lot of great up until this point. We just have to see this through to these last few minutes. Well, and in a few minutes, speaking of that, all the years of thinking, of doing, planning, reacting is finally coming to an end. From 5 minutes to impact, there will be no more opportunity to send any commands to SmartNav in the Mission Operations Center. The team will be purely spectators, the data coming in, and they are just waiting it out like the rest of us for the first time. Lori, this is huge both from an operational perspective and also an emotional one, isn't it?
Yeah, it is. I mean, you can imagine, I'm really excited about it, and I've been engaged with this mission for, the last 4.5 years that I've been in my current role. But this team has been working so hard on this for so many years, and they've put so much of their energy and their time into this, and so much planning and rehearsing, and it's a really big event for them to, like you say, just counting down and watching. At this point, there's not much else they can do but watch and see the fruits of all their work.
Yeah, I've gotten to know many members of this team over the past few months, and there's a lot of alpha individuals on there, right? You need a good mix of alpha people to make sure we get to this point. I can only imagine what they're feeling. Perhaps, like you said, a little bit of relief, a little bit of, can I let this go? I have worked for this moment so long, and now we can no longer do anything. That moment is just coming up.
Yeah, but I think they're ready. I think they're at that point. You're getting some shots of Elena Adams, the systems engineer, and you can see the excitement in her voice. She's so ready to show the success of this mission.
This is awesome. 5 minutes out, which we're coming up on now. The team will be hands off 2.5 minutes from impact. SmartNav, which has been guiding the spacecraft autonomously for 4 hours, will also step away, stop any maneuvers. DART will simply be coasting to its fate. This is blockbuster stuff, Lori.
Oh, yeah. Oh, yeah. We are there. Yeah.
I have front row tickets, and we are very soon about to open up these airwaves in the Mission Operations Center. We'll stay plugged in all the way through impact. Remember, at this point, 5 minutes out, no more commands to SmartNav will be possible. The team is watching it just like you and me and the rest of us. All right, we've reached 5 minutes from impact. The final command opportunity to SmartNav has passed, and the team is simply watching that data stream in just like we are. Also remember, there is a 38-second lag for the data to travel to Earth, and also an additional few more seconds for image processing. It's important to note that. You should be hearing the chatter in the Mission Operations Center momentarily.
This is Dart MSC on DTMOG. 5 minutes till impact. 5 minutes till impact. We are at 1,100 miles away. Also, our window for sending any commands to the spacecraft is done. Contingency's done.
This is a great vibe in that Mission Operations Center right now, Lori.
It really is. They are so excited. And
investigation
I'm honing in, looking at these images as we get closer and closer, and you look at Didymos, and just you're starting to see this physical body appear there. It's incredible, just incredible.
Great.
I'm still having a hard time believing this is real imagery coming in near real time.
Yeah, but you've been watching it over the last 30, 45 minutes go from just being a collection of individual pixels, and now you can actually see the shape and the shading and texture of Didymos, and we're going to see that same thing with Dimorphos as we get closer and closer. This is so cool.
Never before seen images of Dimorphos will come into stark relief.
Absolutely.
A few seconds before impact.
Didymos. It's amazing.
Yeah.
All right.
نعيش الحدث مع صوت مباشر لناسا.
55 minutes ago, we couldn't even resolve this object in space, and now you can see us zeroing in right on target.
And we're now dropping the clock, and we'll go by loss of signal to confirm impact.
Right. Yes. Imagine we'll get that loss of signal, and then we'll hear from Lena Adams again, letting us know that we've been successful.
I feel like that'll be a crystal clear signal.
I think so. I think we're starting to see more resolution. In fact, look at that. Didymos has even gone out of the view. We're now just seeing Dimorphos.
This is remarkable stuff.
Oh my goodness, look at that.
Looks like control system settling down. Angular rates look really good. I think we're going to get the investigation team some good pictures.
Wow.
No, come on, we can do better than that.
Starting to see those individual boulders there. You can see shadows of the various rocks on the surface.
It's amazing, guys. Oh my goodness, look at that. Unbelievable.
Yeah. Looks to me like we're headed straight in. Oh my gosh. Oh, wow.
Yeah. goodness.
Yeah.
8, 7,
Oh,
6,
wow.
5, 4, 3, 2, 1.
Oh my gosh. Oh wow.
Awaiting visual confirmation.
All right. Let's see. We got it? Waiting.
And we have impact. A giant leap for humanity in the name of planetary defense.
Woo. Fantastic. Oh, fantastic.
What a moment. Very few words can really capture this moment. This is beautiful to watch. Amazing.
What a team. What a team and what an accomplishment.
Team. A few weeks ago, they had their last dress rehearsal. They were getting emotional at the dress rehearsal, and they're like, this is crazy. We're getting emotional. This is not the real thing. I can only imagine what they are feeling right now.
Yes. Well, you can see them there on screen. They're all pretty excited. Wow.
Hearing impact, the curtains close on Draco feed. That raw joy from the team, years of hard work and the weight of expectation lifted off their shoulders. This is amazing.
Fantastic.
This is beautiful. And Lori, really, this is a huge moment for the mission. Lots more work needs to happen in the days, weeks,
Absolutely. Now, as I always say, it's one of my favorite missions. Now is when the science starts. It just starts now. Now that we've impacted, now we're going to see for real how effective we were. We're going to train all of those ground-based telescopes on the Didymos Dimorphos system, and we're going to make measurements that will help us determine just what its orbit looks like now relative to what it was before. So it's going to be great. Very cool.
All right, this is when science, engineering, and a great purpose, planetary defense, come together, and it makes a magical moment like this.
Yeah.
قلنا أصدقائي العملية كانت ناجحة في الاصطدام. شفنا الصورة كيفاش المركبة دارت اصطدمت إلى آخر لحظة. الكاميرا كانت تصور الاصطدام، عملية الاصطدام. العملية كانت ناجحة في الدقة، ولكن النتائج ما زلنا ما نعرفوش النتائج. كما قلت بكري، فما بتي ساتيليت إيطالي، هو إيطالي الصنع، موضوع على المركبة دارت، ومقرر أن ينفصل عنها قبل الاصطدام، وباش يبقى بعيد تقريبا في حدود 55 كيلومتر على موقع الاصطدام، وباش يعطينا صور لعملية الاصطدام. طبعا تقنيا ربما منعرفش تاخذ وقت الصور هذه باش توصل، أو تاخذ وقت للمعالجة. ما نعرفش باش يعطونا توا صور وإلا لا. أنا زلنا في المباشر نتابع معكم في العملية. إذا المفيد بالنسبة لنا هو الاصطدام كان بكل دقة. وقع الاصطدام حسب التقديرات، حسب المخطط له، وإن شاء الله يعطونا صور سريعا. مش يعطونا صور وإلا لا. هو حتى ما كانش فما صور فورية للحدث. طبعا من هنا الغدوة إن شاء الله يعطونا صور ونهبطوها إن شاء الله على القناة نشوفوا شنو وقع تغيير مسار الكويكب أم وقع تهشيمه أم شنو وقع بالضبط ما نعرفوش. ننتظروا صور لوكالة ناسا. Peut-être j'explique un peu en français. On était en direct pour suivre cet événement de défense contre les astéroïdes. L'humanité veut se défendre contre un éventuel astéroïde qui peut percuter la Terre. Et ça sera très grave et très dangereux pour la Terre. Ça sera destructif. Donc on a pensé à intercepter les astéroïdes. C'est une première, c'est le premier test. Cette sonde DART, c'est une abréviation de double Asteroid Redirection Test. Ce soir, elle a percuté un astéroïde, c'est Didymos, qui fait 780 mètres. En fait, elle n'a pas percuté l'astéroïde lui-même, elle a percuté une lune de cet astéroïde, c'est Dimorfos, qui fait 163 mètres de diamètre. La vitesse de la sonde était aux alentours de 23 000 km par heure. Sa taille n'est pas très grande, la sonde, mais son poids c'est de l'ordre de 570 kg. Donc elle a percuté exactement cette lune d'astéroïdes comme c'est prévu du point de vue temps, du point de vue impact, lieu de percutation. Et on n'a pas, jusqu'à maintenant, on a suivi en direct la caméra de la sonde qui a filmé tout, mais après on ne sait pas, on n'a pas d'image jusqu'à maintenant. On disait qu'il y a un satellite, un petit satellite, un micro-satellite collé sur la sonde qui va se détacher de la sonde avant le phénomène et il va filmer tout. C'est prévu qu'il reste à peu près 55 km. Donc, c'est une première. Bien sûr, s'il y a des images de ce satellite ou bien une vidéo, on va la suivre ensemble. C'est le directeur de la NASA maintenant qui... voilà, c'est la sonde DART. Il parle de la construction de cette sonde. Bien sûr, un projet comme ça demande beaucoup de temps, beaucoup d'investissement. Énormément d'ingénieurs qui font ça. إذن أصدقائي الوقت متأخر ربما ما نجموش ننتظروا الصور كما قلت أنت الساتيليت اللي هو ميكرو ساتيليت اللي هو قمر صناعي صغير جدا، قلنا باش ينفصل على المركبة دارت ويبقى بعيد على الحدث هذا، على الاصطدام والانفجار. الساتيليت هذا طبعا باش يصور لنا، باش يعطينا صور إن شاء الله نشوفوها مع بعضنا، صور الاصطدام.
To do something like this, a technology demonstration that who knows someday could save our home.
Very powerful. Thank you, Pam. Ralph, you were in that mock for the moment of impact. We've seen a lot of major milestones in APL's history in space. We're talking the first flyby of Pluto, the first mission to orbit Mercury, and now the first spacecraft to impact an asteroid. What was the moment like for you in there?
It was incredible to see how so many years of hard work and creativity resulted in a direct hit of Dimorphos was just an adrenaline rush. I'll add that I've been at the lab now for quite a few years, and I've been involved in a lot of missions and achievements, and never before have I been so excited to see a signal go away and an image to stop.
Ralph, I'm going to give you both a treat right now. We're going to play that replay of impact on our screens right now so we can enjoy it again. Ralph, what does this achievement mean for Johns Hopkins APL? Huge, right?
Oh,
إذن أصدقائي مشكورين على وجودكم معنا. مواكبة هذا الحدث نعاود نشوف الصور كيفاش اقتربت المركبة دارت هذه من القمر هذا نتاع الاستيرويد. نشوفوا الفينومين إعادة ريبيتيسيون ولا le choc entre la sonde Dart et Didymos اللي هو قمر للكويكب ديدايموس. نعاود نشوفوا الاصطدام من جديد، نشوفوا الاصطدام. الكاميرا مثبتة على المركبة دارت، تقترب شيئا فشيئا. نشوف الدقة في المسار والاصطدام. ما بعد الاصطدام موكول لميكرو ساتيليت، قمر صناعي صغير كان مثبت على المركبة وانفصل عنها باش يبقى بعيد مسافة 50 أو 55 كيلومتر باش يصور الحدث. لكن للأسف التو ما عندناش صور نتاع الساتيليت هذايا. شفنا عملية الاصطدام فقط. هي السرعة هائلة، علاش الاصطدام ممكن يتسبب في تشييم أو تكسير للكويكب أو تغيير مساره. وفي الواقع يسعى إلى تغيير المسار فقط. إذا مشكورين أصدقائي على تواجدكم. إن شاء الله نكون معكم. إن شاء الله قدمت حاجة واضحة، فسرت باللغة العربية. طبعا عديد المواقع تعدي في الأحداث هذه بلغات مختلفة. إن شاء الله نكون بلغت باللغة العربية، وأن هذا هو الهدف من القناة. طبعا إن شاء الله نكون معكم في مواعيد أخرى، وتكونوا أوفياء القناة وتشاركونا بالإعجاب وبالمشاهدة وبالمشاركة. ومشكورين إن شاء الله في أحداث قادمة. إلى اللقاء. تحيات أسترو دوز.